Hello and welcome everyone. In this video tutorial, we will discuss about the concept of thread synchronization in Python. And we will start off this video tutorial by discussing the need of thread synchronization. Then we will give a brief introduction to what is this thread synchronization, and then we will discuss about some of the methods of implementing synchronization of threads in Python. So without any further delay, let's start with the very first topic. Basically, with the aid of many CPUs or cores, multi-threading enables our computer system to carry out tasks concurrently. However, it can produce inaccurate results when reading and updating shared variable simultaneously. So the use of multi-threading expands computing capability. However, there is a common issue related to it where multiple threads trying to access the same piece of data might cause an issue. For example, incorrect data or output that is jumbled, which is obviously difficultly one can imagine with multi-threading. Such cases may occur when we don't instruct the computer to manage threads in any orderly manner. The situation of accessing resources with the shared resource simultaneously may result in race condition. So what is this race condition? A race condition usually occurs when multiple threads have access to common data and attempts to modify it simultaneously. Thus, depending upon the timing of the previous context shifts, the values of the variable may be unexpected. Now let us understand this whole arrays condition with the help of an example. So on the screen here you can see I have opened my Jupyter notebook. In this, let's look at the very first example. So what we have done in this example, I have imported the threading module. So to implement multi-threading here, I am using the threading module. Then I have also imported the time module. Then I have defined this global variable, that is x, and I have assigned its value to 10. After this, I have defined a function with name increment, which takes an argument value, and it basically what this increment function will do, it will use the global variable. It will basically take an input and it will use that input value to increment the value of x. So that's why here we use the global x variable. Then we define a counter which increments the value of x and then reassign to x only. Then I have also used this function, that is current underscore thread. I've used this function to fetch the name of the current thread, and then it is simply going to print the current value of x and the value by which it will be incremented. Then outside of this function, here in the main thread, what I have done, I have defined this thread t1 using the thread class, where the target is increment function and the input for that is 6. And then I have defined another thread t2 which will execute the increment function with an input of 8. Then I use the start method to start the thread and then join method to complete its execution, and in the last we will print the final value of x. So let me execute this code block. So here you can see the execution. First thread 5 is there, which increments the value of x by 6, and after increment the value of x gets 16. So earlier in the program we have defined the value of x as 10. After incrementing the value of x by 6, the value of x becomes 16. Then thread 6 got executed, which increments the value of x by 8. But again here you can see the value of x becomes 18, means thread 6 has overwritten the task done by thread 5, and in the last we got the value of x as 18. So this is a common example related to race condition. So what actually should be done in this program, that first, if the thread 5 is incrementing the value of x by 6, then we got the value of x as 16, and then thread 6 should increment the value of 16 by 8 and then return the result, which should be 24. But we are not getting that result because of the race condition. Now to overcome this race condition, we generally utilize the concept of thread synchronization in Python. So let us discuss that. So with the help of thread synchronization, we can protect a shared resource by ensuring that the shared resource is accessed by one thread at a time. Now in Python, locking technique is one of the common ways to implement thread synchronization. So let us discuss how we can do locking with the help of this lock class. A primitive lock is used in Python's threading module for effective multi-threading, which can be synchronized two or more threads with the aid of this lock. Perhaps the simplest synchronization basic in Python is provided by this lock class. By using the lock class, we can lock a resource for a particular thread, and once the task is completed, we can unlock or release that resource. When we initialize the lock object, the primitive lock, which has two states, first one is lock and second one is unlock, is generated in the unlocked state, and there are two methods related to it. First one is the acquire method. Now what is this acquire method? The acquire method is utilized to obtain the lock state. Moreover, when we use this method without any parameter, it blocks the lock until it has been unlocked. And after this, the another method is the release method. So as the name specifies, the release method is utilized to release or unlock the obtained lock. This method will return after resetting the lock to its unlocked state if it is been locked. However, if an unlocked lock is used to evoke it, it will return a runtime error. Additionally, one of the threads always waiting to acquire the lock is permitted to hold it when this method is being called. Let us discuss the use of this acquire and release method with the help of an example. And for this, I will move back to my Jupyter notebook. Now again, we are using the same example of increment function. What we done in this, we imported the threading module, we imported the time module, we defined the global variable x as 10. Then we define our increment function. So what this increment function will do, it will take the val which is specified as an argument to this function and increment the value of 10 by that given value. Now what we have done with this, you can see one more lock argument is being passed to this increment function. So this lock is a lock object here. So once we pass this lock object, we will use the acquire method with it to acquire the lock, execute all the tasks, and in the last it will release the lock using the release method. Now let's come to the main execution. So we use the lock class to define the lock object, and then we define two threads T1 and T2, and while passing the value we also pass the lock object to both the threads. So once T1 will execute, it will take the value of 6 as an argument to this increment function as val, and it will also take the value of lock, which is a lock object. Then we started the thread using the start method, and we join the method, and we also use the join method to complete its execution, and remaining code is same only. In the last we will return the final value of x. Let me execute this code block, and here this time you can see there is thread 7 which increments the value of x by 6. Value of x becomes 16. Then the thread 8 executes the increment function, taking the value of val as 8 and incrementing the value of x by 8, which means 16 plus 8 becomes 24, and in the last we got the value of x as 24 as our final result. So in this way we can implement thread synchronization in Python using the lock class. However, there is one more method related to synchronization, that is semaphore. Now the lock class from the threading module only permits one thread to run at a time. However, there are instances when we need to run certain number of threads concurrently. Let us take this thing with the help of an example. For example, there are 6 users who want to access the database at a given time, but only 2 users can use the network, and the lock class cannot handle these kind of requirement. So to manage these type of requirement, we use semaphores. Semaphore can be utilized to restrict access to the shared resources with constraint ability, and we generally use this semaphores for more complex thread synchronization. A semaphore is merely a variable that shows how much resource are at hand right now. A semaphore is something like a parking lot with a sign indicating how much or how many spaces are available on a particular level of a mall. The value of semaphore cannot be larger than the entire number of resources available, or it should not be less than 0. Moreover, just like the object of lock class, semaphore object is also connected with the acquire and release method, so we can use both of them with the semaphore as well. Now how we can use this semaphore, let's discuss this thing with the help of an example. So in this example, again we imported everything from the threading module, then we also imported the time module, then we define an object of this semaphore with an argument value of 3, and we name this object as obj. Then we define a function which is getInfo, which takes an input as value. Then we use this semaphore object to acquire and release the resources, and it will simply return a print statement related to Python guides, and it will return a counter related to it only. Then we define two threads T1 and T2, where we have passed the argument value as thread 1 and thread 2 for T1 and T2 threads. Then we started the thread using the start method. Now let's execute this code block. So here you can see each thread, that is thread 1 and thread 2, are executed three times. So in this way we can have thread synchronization using the semaphore. And with this, I hope you all get an overview related to thread synchronization in Python. And we also come to the end of this tutorial session. Thank you so much for watching this video. We will see you in the next one.